In this video, we consider double integral in polar coordinates. Before we start solving some examples, let's consider how to convert a double integral from the Cartesian coordinates to the polar coordinates. So to convert a double integral from the Cartesian coordinates to the polar coordinates, we use the following identities. Wherever we see x, we are going to substitute r is equal to cosine of theta. Also, wherever we see y, we are going to substitute r is equal to sine of theta. And x squared plus y squared will now be giving us r squared. And finally, the x dy will be equal to r dr d theta. So with this in mind, we can now solve some examples. With our first example, we are being asked to compute the integral of this guy. Now here, y is the inner integral, so the range of y is from 0 to square root of 4 minus x squared. And the range for x is giving us 0 to 2. To solve this question, we write out the ranges of integration. So here we have x lying in between 0 and 2. And y also lies in between 0 and square root of 4 minus x squared. Our next step is to graph these inequalities. So graphing the inequalities gives the figure below. Now our main focus is to find the radius r and the angle theta. So now here our focus should be on the area where the two regions meet. So these two regions meet here. So then the radius will be from the center, which is 0 to 2. So that will be r will lie in between 0 and 2. And also our angle will be from 0 to pi on 2, because we are going to trace the angle from here onto this side. That's where the two regions meet. So theta will also lie in between 0 and pi on 2. So now we now have everything that we need, so we can now set up our double integral in the polar coordinates. We now set up our double integral in polar coordinates. So we are going to have the double integral. Then this function is giving us e minus x squared minus y squared. So we can factor out minus, so that'll be minus out. Here we left it's x squared plus y squared. And we are also being told that dy dx is now giving us r dr d theta. So this side will be r dr d theta. And we also know that x squared plus y squared is r squared. So thus we are going to have our integral to be the double integral e minus r squared r dr d theta. Then the range of integration will come. Here we are integrating with respect to r first. So we are going to have this range to be from 0 to 2. Then the theta will be from 0 to pi on 2. Now we can now solve our integral. So we can rewrite this guy as integral from 0 to pi on 2, from 0 to 2, r e minus r squared dr d theta. To integrate this guy, as we did in the previous video, we take out the inner integral, then we integrate that one first. So we are going to have integral from 0 to 2 r e minus r squared dr. To integrate this, we use u substitution by letting u to be equal to minus r squared. So this is going to give us minus 1/2 e minus r squared. Then the range of integration from 0 to 2. Evaluating this gives minus 1/2 e minus 4, then minus 1/2 e exponent 0. So this is going to give us minus 1/2 e minus 4 plus 1/2, because e exponent 0 is 1. Factorizing 1/2 out gives 1/2 out 1 minus e minus 4. So the next step is to substitute this guy in place of the inner integral. Thus, we are going to have integral from 0 to pi on 2 1/2 1 minus e minus 4 d theta. We now integrate this guy. So now here we should note that this guy is a constant, right? So since the integral operator is linear, we can factorize the constants out. So that's going to give us 1/2 1 minus e minus 4 out, then the integral from 0 to pi on 2 d theta. Thus we are going to have 1/2 1 minus e minus 4 theta from 0 to pi on 2. So substituting the range of integration gives 1/2 1 minus e minus 4 pi on 2 minus 0. So thus our answer will be giving us pi on 4 1 minus e minus 4. Hence our answer is given below. With our second and last example, we have to evaluate this guy in polar coordinates. Thus, we first have to convert it to the polar coordinates. Then we can now evaluate our results in integral. The first step is to sketch the inequalities, right? So now here, x lies in between minus 1 and 1, and y lies in between minus square root of 1 minus x squared and 0. So we're going to have our inequalities to be minus 1 less or equal x less or equal 1, and y also lies in between minus square root of 1 minus x squared and 0. So now we first have to sketch these guys. Sketching these inequalities gives the region below. So now here our focus is where the two regions meet, so that's this guy. So we just have to find our radius and our angle theta. So here the radius of this semicircle is 1 because the radius will be from 0 to 1. So r will lie in between 0 and 1. Now let's find the angle theta. So we are going to trace the angle theta from here to this side, right? That's we are going anti-clockwise. So that's the angle will also be giving us from minus 2 pi to minus pi. So that's our angle will lie in between minus 2 pi less or equal theta less or equal minus pi. So we now have everything that we need to solve this given question. So let's set up our double integral. Thus we are going to have the double integral cosine of, so we know that x squared plus y squared is equal to r squared. So here is going to be r squared, and also we know that the x dy is giving us r dr d theta, and the range of integration will be, since we are integrating with respect to r first, here should be from 0 to 1. So that's going to be 0 to 1, and theta will be from minus 2 pi to minus pi. So we now have to integrate this guy. So we can rewrite this integral to be minus 2 pi to pi, then 0 to 1, r cosine of r squared dr d theta. Here we take out the inner integral, then we evaluate that one first. So you're going to have integral from 0 to 1, r cosine of r squared dr. Here also we use integration by u substitution. So we let u to be equal to r squared, then we evaluate. Thus we are going to have 1/2 sine of r squared, then from 0 to 1. Substituting the range of integration gives 1/2 sine of 1 squared is 1, so that will be sine of 1 minus 1/2 sine of 0. And sine of 0 is 0, so that's going to give us 1/2 sine of 1. Our next step is to substitute this guy in place of the inner integral. So doing this, we are going to have integral from minus 2 pi to minus pi 1/2 sine of 1 d theta. So we just have to integrate this guy with respect to theta, and that's going to give us 1/2 sine of 1 theta, and then the range of integration minus 2 pi to minus pi. Substituting the range of integration gives 1/2 sine of 1, then minus pi minus 2 pi. So thus we are going to have 1/2 sine of 1, then pi. Hence our result is given below. Thank you for watching. See you in the next video.